Hello, and welcome back to another Orange Coast College mathematics video. In this video, we're going to be talking about graphing the sine and cosine function. Of course, you've had some experience graphing before, and you can always graph by plotting points. We have here shown the graph of sine of x, which of course you can verify by plugging in values like the sine of 0, the sine of pi over 2, the sine of pi, the sine of 3 pi over 2, and so on to plot some points. But what it turns out is that the sine graph looks like a wave. In fact, it's pretty useful for anything having to do with waves, light, sound, anything that's transmitted in waves has trig involved in it. So we're going to talk a little bit about graphing them. And while we can graph sine, we also want to graph transformations of the sine function. There's a couple key properties of a graph. Because it's a wave, we can talk about its amplitude. That's sort of how far it is from the distance of equilibrium. That would be this value, and that is the absolute value of what you're multiplying sine by. Because sine normally can get as high as 1, but if you multiply it by something, it can get higher. And the period is how long it takes before the wave starts to repeat itself. So here, we know from the unit circle that things start repeating after 2 pi. So sort of the standard period is 2 pi, but if you multiply the x by something, that can affect the period, and you have to divide out by that b value. So let's go ahead and jump in with some examples. Let's say we wanted to graph y is equal to 3 sine of x over 2. The sine function goes on forever, it keeps repeating. So how much we want to graph is just dependent on what it is we're trying to show. In this case, we're only trying to graph one period. All right, so we've got y is equal to the 3 sine of x over 2. I'm going to start by figuring out what that period is so I can set up my axis. I know normally the period is 2 pi, but I have to divide by the b value. What is the b value in this problem? Well, this can be rewritten as 3 sine of 1/2 x. So that 1/2 is going to be our b value. That's the thing we're multiplying x by. So this period is going to become 2 pi divided by 1/2, which is of course the same thing as 2 pi times 2 over 1, which is 4 pi. So we're going to repeat after 4 pi. And our amplitude is going to be the absolute value of 3, which of course is just going to be 3. It just means that if there's a negative here, that doesn't really affect what the amplitude is. It's a positive number. So I'm going to set up some axes. When I set up my axes here, I'm going to need a y-axis. Going to need an x-axis. And as we can see up here, the period is sort of typically broken into 4 parts, 1, 2, 3, 4. And so I'm going to do the same thing here, but in this problem, I know it's going to repeat after 4 pi. So I'm going to break that 4 pi into 4 fourths, or into fourths. And so I get pi, 2 pi, 3 pi, and 4 pi. You can do that by dividing 4 pi by 4 to get pi. That will tell you what you need to sort of label your axes as. Then I have an amplitude of 3, so I'm going to go up 1, 2, and 3. It's very important when you're doing this that you're labeling your axes. So following the pattern, we start at 0. Then instead of going up to 1, we go up to 3. Then instead of, the 2 pi is still going to give us 0. We're here. Then we're down here. Instead of at 1, we're at -3. Oops, I forgot my negatives here. And then at 4 pi, we're back at 0. So those are my points, and then I can connect them with a graph that will look something like this, a nice wave. And it's just a sketch. You're not going to be perfect. What you want to make sure you do is you want to make sure that it looks like a curve. You don't want to connect these with straight lines because it's very much a wave. But as long as it looks curved and you get the general idea, you're going to be in good shape. All right, on this next problem, we're going to do the same kind of thing, but we've added a couple additional pieces to this. We've got transformations, or specifically translations. We're adding -2 to it, and we're shifting the inside by this pi. And so we're going to have to deal with that and figure out how that's going to work in this problem. Okay? The first thing I'm going to do is I'm going to rewrite this function as -2 plus 4 sine of. I'm going to factor out a 2. So maybe for good measure, I'll change this to a bracket. Sine of 2 times x plus, I factored out a 2, so I get left with a pi over 2 here. The reason I do that is because, as you've seen in past graphing videos, we really need to make sure that when we're trying to figure out what we're shifting by, that shift is applying directly to the input variable, that x. So let's identify some key. Now that we have it in this form, we can identify some key things. The period is going to be 2 pi divided by that 2, which is pi. The amplitude is going to be the absolute value of this 4, which is 4. We can figure out what we're going to count by, our units by in a second. We have a period of pi, so pi divided by 4 is going to be what our units are going to be. And then we're going to have some shifts. Because of this minus 2, we are shifting down 2. I'm just going to use that arrow because it's nice and visual. Now, this pi over 2 is a shift, and remember, because this pi over 2 is being applied directly to the x, we are going to have a shift of pi over 2, not in the positive direction, but the negative direction, pi over 2 to the left. All right, so let's go ahead and set this up. We need to set up a set of axes. We know we're going to be canceling or counting by pi over 4s, and my period itself is pi. So I'm going to have a length of pi, but I'm starting pi over 2 to the left. So what I'm going to do for my axis here is I'm going to set it up where I have some space on either end to work with. And I'm going to go to the left pi over 2. Here's pi over 2, negative. And then we're going to go to the right pi over 2. And these intermediate steps are negative pi over 4 and pi over 4. Notice from negative pi over 2 to pi over 2, we have a whole length of a period pi. That's what we wanted. Negative pi over 2 is where we start. Pi over 2 is where we're going to end. That takes care of the period. That takes care of the shifting to the left. Okay. Now, we have an amplitude of 4, but we shift down by 2. So how does that sort of translate? Well, you can do it in your head, or what I like to do is sort of label stuff here. I've got -1, -2. Because we've shifted down by 2, I can think of this sort of dotted line here as my new x-axis, as my new equilibrium point for my function. Now, because I have an amplitude of 4, I can count up and down from there. At negative pi over 2, I'm just going to stay at equilibrium, just as we did up here. At pi over 4, I'm going to have to count up 4, an amplitude of 4. 1, 2, 3, 4 puts me up here, which would be at the point, a y value of 2, because we started counting from the point of equilibrium. Then at 0, I will be back down. We're just continuing the pattern, right? And then at pi over 4, I'm going to have to go down 4. 1, 2, 3, 4 puts me down here all the way at -6, -3, -4, -5, all the way down here at -6, and then back to equilibrium. And so to sketch this, it's the same shape, right? We get the same sort of wave function happening. And so as you can see, it's very important that we sketch our graphs, that it's very important that we label our axes, or else our sketched graphs will look all the same. Like they're all going to have roughly the same picture. It's really about where it's positioned in the coordinate plane and what those units are. Let's go ahead and do a couple more, but now we want to work with cosine. Cosine is actually exactly the same wave as sine, it's just shifted over. It has the same pattern, it just starts at 1, goes to 0, goes to -1, goes to 0, goes to 1, but it is otherwise exactly the same graph, just shifted. So for this first problem, we can start off exactly the same way. Everything is basically the same, we are just going to use different points at the very end. So the first thing I'm going to do is I'm going to factor out this 1/3. If I do pi over 6 and I divide out by 1/3, that's the same thing as multiplying by 3 over 1, and I get pi over 2. So my shift ends up being this minus pi over 2. That is going to give me what? I have a period of 2 pi over 1/3, which is the same thing as multiplying by 3, and I get 6 pi. The amplitude is going to be 3, and I have a shift of pi over 2. This is a negative, so we're shifting to the pi over 2 in the right direction. Okay? Because my period is 6 pi, what am I going to be counting by? Well, 6 pi divided by 4 is 3 pi over 2. So I'm going to be counting in multiples of 3 pi over 2. So let's go ahead and sketch a graph of this. So I'll get a vertical axis going, I'll get a horizontal axis going. We're shifting to the right, so it's all going to be on the right. If I label this guy as pi over 2, then I have to count by 3 pi over 2's, right? I know pi over 2 is going to be my starting point because of this shift, and I want to count by 3 of those pi over 2's each time. So I'll get a point here, a point here, a point here, and looks like I'm out of dots a little bit, so I'll just make some more myself and go to a point here. And so this is going to be 2 pi. 2 pi plus 3 pi over 2 is 7 pi over 2, plus 3 pi over 2 is 5 pi, plus 3 pi over 2 is 13 pi over 2. So I know I'm going to start at this point, and I'm going to end at this point. So that takes care of the shift. It takes care of the period. The only thing left to do is make sure I handle the amplitude correctly. So for my amplitude, pi over 2 starts at 1, but we're multiplying by 3, so I'm going to start up at 1, 2, 3, and I'm going to have to go down 1, 2, and 3 as well. At pi over 2, I will now be up at 3, then I will be down at 0, then I will be down at 3, then I'll be up at 0, then I'll be up at, instead of 1, I end up at 3. And so it might be very tempting to see this and be like, oh, I can just connect this with a straight line. But remember, it's a wave. So it curves down and it goes back up. And of course, this repeats forever, but we're only being asked in this problem to graph one period. All right, one more problem to round off the video. This problem is interesting because of this negative value. We'll talk about how to deal with that here in a second. But first, I've got a period of pi, or 2 pi divided by that pi, rather, which is 2. 2 divided by 4 is 1/2, so that's going to tell me what to count by. I've got an amplitude of the absolute value of -4, which is 4. I've got a shift up in the y direction by 1, so I'm going to say up in the y direction by 1. And the only other thing that's different about this problem is, what does that negative really do? Well, we'll talk about that in a second, but let's go ahead and start setting this up. So we'll go ahead and set up our axis here. No horizontal shift, so we're just going out to a period of 2, broken into 4 pieces. So here's my 2, that broken into 4 pieces. This is 1/2, 2 halves, 3 halves, and 2. I'm going to be shifting up by 1, so really that sort of axis of equilibrium here is going to be along this dotted line. That's where we're going to start counting from. And now I have an amplitude of 4, but my outputs are being multiplied by negative values. So instead of cosine would normally start by counting up 1, 2, 3, 4, we're going to count down 1, 2, 3, 4. And I'm going to end up at a value of -3. can label this while we're at it. Okay, so we'll start down here. Then 0 is still just going to be 0. Then in the middle, normally like in this last problem, we went down by the amplitude, but because of this negative, we're going to go up by the amplitude. Up, 1, 2, 3, 4. We end up up here, and we just continue the pattern from there. And so my graph looks something like that, and like that. All right, and that's the basics of how you graph transformations of sine and cosine functions. If you're ready, feel free to move on to the next video where we will talk more about graphing.